Hi everybody, I thought we'd have a quick look at fraction definitions. So let's start with what a whole looks like. A whole looks like we've got something and we want to count all of it. So in this case we have a rectangle, we want to count the whole rectangle. Now in the second case we have part of a whole, so we have this part here. Now that's an important definition because this is saying that we don't want the whole of the object anymore, we just want a portion of it. Now the third definition is we've got an equal sized parts in our whole. So we've got this part here and this part here are the same size. And then we've selected one of them. So we've selected this left hand side part. Now it's this definition here that allows us to make fractions. We can make fractions with this, but we have to do work first. We don't need to do fractions with this because it's already defined as a whole, and wholes are defined in terms of integers. And we'll see that in a sec, or at least in the next presentation. So to name a fraction, parts must be equal sized. They must be like this. So in this case, these are equal sized, they're all squares. These are equal sized, they're all equally sized rectangles. Now once we have equal sized parts, we can count the parts selected and the total number of parts that we have and make a fraction. So in this case we have 4 parts, 1, 2, 3, 4. That tells us to put 4 on the bottom because we have 4 equally sized parts out of our whole, which is in this case is a square. Now of those 4 parts, 2 of them have been selected, 1, 2, and that's the number that we would put on the top. So 2 parts out of 4 have been selected in this shape, 2 equally sized parts. Now in the second one, we still have equally sized parts, which is great, which means we can turn this into a fraction too. Here's 1 here, 1 here, 1 here, 1 here. And out of those 3 equally sized parts, we've selected 4 of them. So there's still 4 equally sized parts, just like in our example over here. 1, 2, 3, 4, that number goes on the bottom. And we've selected 3 of them, that number goes on the top. So 3/4 describes the proportion of this shape that we've shaded, and 2 parts out of 4 describes the proportion of shapes we've shaded in this case. The size of the parts don't matter as long as we're describing, as long as the parts we're describing in them are equally sized. So we have to be a little bit mindful though of when we're comparing 2 fractions. So here's 2 chocolate bars. Pretend they're to scale. This chocolate bar here is a little bit smaller than this chocolate bar. In both cases we've got 1 part out of 2 equally sized parts shaded. That's a half, this is a half. Which one would we want? Well, obviously we want bar 2 because we'll get more chocolate. So what we're dividing into parts is important to consider. Now also we should consider what the fraction means. So we've got these 2 different sized chocolate bars. In this one I've split it into 4 equally sized parts, and this one I've split it into 2 equally sized parts. So in this case I've shaded 3/4, and in this case I've shaded a half. Now you might think, well, 3/4 is more than a half, I want 3/4, but you can see that I'd get more chocolate from this one still. So when looking at fractions, the size of what you're making into a fraction is important if it's been given to you. If we're just assuming that they're both the same size, we can just compare the fractions themselves. And I think that's it for this one. So thanks, I hope that's helpful.